Now we're at the third video. I don't know if there's going to be a fourth one, but we'll see if we can go and take it out from here. Okay, we are now on problem number 9, where we talk about the domain and range of this graph. Remember, the domain is all of the x values in the graph. And this is a parabola. It goes on forever. So if I look at it as it relates to the x-axis, then basically it's going to be the entire x-axis because it's going to go from here to there. Okay? There's no minimum. There's no, look at there. What is the minimum x point? There isn't one. What is the maximum x point? There isn't one because this goes on forever. This goes on forever. But if I look at the range of the graph, I have a maximum point here at 1. That's negative 1. So at y equals negative 1, that looks like a 4, even though I said negative 1. Let me see if I can make that better. If I look at y equals negative 1 right there, then the range of the graph looks like this. So y is less than or equal to negative 1. And then in the notation that they're using on this problem, they also have it, that's y is between negative infinity and negative 1. It's the same thing as just having just y equals less than equal to negative 1. Anyway, that's what you're looking for. So here is, if we look through this, we only see that one place where y is less than equal to negative 1. Well, we see it here and we see it there. And the only problem is here x is not all real numbers, and here x is not all real numbers. So the only place where I find it, and it looks like I'm kind of covering it up, is choice D. So choice D is the only one that says x is the entire x-axis and y is less than negative 1, because this is the domain that's from negative infinity to positive infinity, and then the range is from negative 1, less than negative 1, to negative infinity. So the answer is choice D. All right, let's move on. Which of the following does not have zeros at x equals 5 and x equals negative 6? Simplest way to do this is just to graph each one of these, and you will see what the zeros are. If you graph, so we're looking for which one. If we graph D, look at D. If we graph D, okay, and let me get rid of all this extra stuff. I believe it was x squared plus x, which is still 1x plus 30. If I graph that, look, it doesn't even have x-intercepts. And the reason why it doesn't have x-intercepts is because it's way up here. Look at that. So it does not have x-intercepts. So that is obvious. That is so obviously the answer to this problem. So it doesn't have any x. It doesn't have any zeros. So the answer here is definitely D. D has no zeros at all. And all the rest of them do, if you graph these, they do cross at 5 and negative 6. All right. Look at number 11. Show you how to do this one. This one is much easier shown. First thing you need to do is go to list and spreadsheets. Put that in the calculator. Then you're going to do something called a quadratic regression. Okay, that's what we're going to do. So we're going to put our list in the calculator like this. Then we're going to do a regression so that we get a curve like this. And all we got to do is examine that curve. So let's do that. All right, so let's go to the home key. And I'm just going to, let's put the graph in. Let's see. I believe our x, let's go ahead and say our, do we use x and y? Let's see, I need to go back to the problem. Okay. Yeah, well, it was a missile. So we have time and height. That's what we have. So we use T and H. Okay. So let that be T. And let this be H. Okay. Time and height. We know the time is 1, 2, 3, 4, 5. And we know the height. We look at, let's put the data in from the problem. We got 0, 8, 12, 12, and then it looks like it goes back down to 8. So we got that's what the missile is doing over the first 5 seconds. Okay. Now, unless something miraculously happened, it looks funny. It looks like it went up in the air, stayed at 12 for a whole second, and didn't come down. We know that didn't happen. But let's see what it actually looks like. So that's listing spreadsheets. Now we're going to go to the home page. And now we're going to go to data and statistics. Okay, if you didn't see what I just did, let me redo that because I know that was fast. We were at listing spreadsheets. We went home key, and then we went to data statistics, which is right next to it. So you got to just move the cursor there. Then I press enter, and now I'm going to let my timeline be my x-axis, which makes sense, and then my height will be my y-axis, and there's my graph. So, so those are the measurements of the height. Let's do a quadratic regression to see the curve. Menu, 4, 6, and then 4 again. And there is our graph. And a quick look at this will tell you that the maximum right there, there's a line right there, that looks like that's the maximum right there. I can even show it if I wanted to. Let me just show it. All right, show it. You don't have to do this part. I'm just going to do a plot value and then say if you go to 3.5, there's where the maximum is right there. So, so if I look at my answer choices, the answer choices says approximate the time where the missile reaches its maximum height and when the missile hits the ground. It looks like from our graph, from this one, or actually if I looked at the graph what we just did, it looks like the maximum height was at 3.5. And if I you see how I grabbed that 5.0 and moved its structure, I can see that it hits the ground just after 6 seconds. So that points clearly, very clearly to choice C. So choice C says that T.5, the missile reaches its maximum height, and T equals to 6. The missile hits the ground. That's exactly what our graph shows. Okay? All right. And is this the same? No, this is different now. All right. And finally, let's look at number 12. Let's see, I believe that's where we'll stop. We'll just look at, the rest of these we'll go through real quickly. All right. All right. So number 12, a football is kicked from a starting height of 3 feet with an initial upward velocity of 40 feet per second. Use a vertical motion formula, ht equals to negative 16t squared plus 40t plus 3, while h is height and t equals time to land. What is the maximum height of the ball? That's all we want to do is find the max of this function. So that's simple. That's a graph trace problem. So let's just home screen, put a graph. We actually probably had a graph somewhere. Well, I'm just going to put it in again. Don't use t, use x. And I need a negative 16. Let's see. Negative 16 x squared. I believe that was a plus 40 x plus 3. All right. There's that graph again. We can use graph trace to find the max. So menu 5, 1. And let's just trace until we get the max. It looks like we're going to go up and up and up. All right. Let's see, I'm not quite there. Oh, yeah, I'm there. So it looks like the maximum is at 1.25. Maximum height of the ball is 28 at 1.25. At 1.25 seconds. So let's see which one. The maximum height, we're looking for the maximum height. So the maximum height is 28 feet. So the answer is choice D. And we use graph trace to do that. Okay. Now, it's not that we could have done this another way. We could also use the graph to find the maximum. If we didn't want to use graph trace, we could also go menu, analyze graph, maximum. Click on one side of the graph and the other side, and it'll tell you the maximum. So there's another way to get the maximum there. All right. Let's see where we are on the time on this. All right. Yeah, let's go ahead and speed this to a close. All right. So, domain, what is the domain and range of the following graph if the parabola was reflected and moved 3 units to the right and 2 units up? And we're just going to imagine this. All right. All right. Right now, the domain of the graph, the domain in the, we know the domain is all real numbers. Not going to worry about that. The range of this graph as it is y is less than equal to -1 because it's the maximum point. If we reflect it, the graph looks like this. It looks like that. And what if it was not only reflected, but we moved it 3 units to the right? It's at negative, let's see, it's at -4. We move it to -1, and then we move it 2 units up. Oops, tore the graph up there, didn't I? Oops, I'll just do it that way. It'd be something like that. So here we've moved the graph over 3 units, and then we moved it up 2. 3 units to the right, and then we use up 2. Well, that means that we're going to end up right here. And that's 1. So now our range is y is greater than equal to 1. Okay. And so which one says that? Greater than or equal to 1. Our x-axis is still, the domain is still all real numbers, but our y is now greater than or equal to 1. And it looks like our choice is A. All right. All right. Yeah, close enough. Actually, yeah, I think that would be our best choice there. Well, hold it. Let's look at D and let's look at A. They look almost the same except for this one says strictly less than and this says inclusive. So actually D is a much better choice because there are no open holes. Yeah, it includes the points. So, all right. So we need that inclusion line there. Okay. So we took this point, reflected it, moved it over 3 to the right, moved it up to 2, and got a new range. Didn't change our domain, but it changed our range. Okay. Look at number 14. Same thing that happens. If you look at y equals x squared, and all you got to do is really just graph it. Well, it becomes just graph all of these and see which one of those looks like this graph reflected and is 4 units to the right and 3 down. That's basically what it is, right? So that's basically what it is. And this is what it looks like. If you got x squared, to reflect it means you're going to have a negative. To move it 4 units to the right means you got to do this. And to take it down 3 means you got to do that. And so that's basically what our answer should look like. And so do we have one like that? Okay. It looks like it's going to be, let's see, let's test it and see that's actually what happened there. So I'm going to take x squared, all right, and I'm going to move it. Let's see, I'm going to help myself a menu 2, 6, 3. All right. And it said, watch this. It says I want to reflect it and move it 2 4 units to the right and 3 down. Okay? So to reflect it, it just means that I am going to take it and put a negative sign in front of it. All right? Then I'm going to move it down 4 units to the, let me get it right. It says, I reflect it 4 units to the right and 3 down. Okay? 4 units to the right, and then 3 down. So I didn't move it down exactly. That's pretty close. So look at there. It's going to be, you can almost see it there. Yeah. 4 units to the right and 3 down. So that's what it looks like. 4 units to the right and 3 down. So if I go down to, so let's go here. All right. 4 units down to the right and 3 down. So my answer there is D. 4 units to the right and 3 down. Okay. And same thing with this. Here, you'll discover that the graph is reflected. It's narrower because we're multiplying by -5, and it's moved up 2. So it's going to be narrow, reflected, narrowed, and shifted 2 units up. The answer there is B. Okay. Draw a parabola that has a minimum and one that has a maximum. Well, minimum looks like that. One that has a maximum looks like that. Other words that mean y-intercept, zeros. No x-intercept. Solutions. Roots. That's another one. Okay. Right? 2 other words to find that mean vertex. Vertex is a minimum or it's a maximum. Okay. I know I'm going fast. And finally, number 16, draw a graph that has 2 x-intercepts. There's one. Draw a graph that has 1 x-intercept. Right there. Draw a graph that has no intercepts. Oh, I am really drawing that bad. That's as good as any. So this one has 2 solutions. This has 1 solution. And this has no solutions. It doesn't hit the x-axis at all. That completes our review. I wish you well on the test.